All right, you guys, let's begin this semester with statistics by just kind of talking about what are statistics. All right, so to begin talking about statistics, we have to start with data. What the heck is data? Data consists of information coming from a number of things. So we can collect data from observations. We can count things and get this word called data. We can take measurements. We can also use surveys and collect responses. All of these are different forms of data. Okay, so here's an example. People who eat 3 daily servings of whole grains have been shown to reduce their risk of stroke by 37%. All right, so here we're looking at data. All right, 70% of the 1,500 U.S. spinal cord injuries to minors result from vehicle accidents, and 68% were not wearing a seatbelt. And so you're seeing these percents. We're talking about groups of people and wanting to put a percent on them. All right, so these are ways we can make sense of data. Whether we're collecting observations or responses from surveys or whatnot. All right, so what is statistics then? Statistics is going to be the science, or I'd like to think the mathematics of collecting, organizing, analyzing, and interpreting data in order to make decisions. You guys, this is everywhere. Businesses use this. Every single field of science uses this. Statistics truly drives just about any newspaper or magazine article that you're going to read. All right, so again, not only is it collecting the data, but it's organizing it, it's analyzing it, making sense of it, and then using the analysis to interpret the information so that we can make decisions. All right, one of the areas where we need to start is by talking about a population versus a sample. Okay, be careful. Don't think population means population of people, all right, meaning everybody on the planet. Okay, a population is just going to be the collection of all outcomes, responses, measurements, or counts that are of interest, whereas a sample is simply a subset of that population. Okay, so maybe our population could be everybody enrolled at USC Upstate. Our sample could be everyone enrolled in elementary statistics. Okay, we could have a population of everyone enrolled in elementary statistics at USC Upstate, but maybe the sample would be just the people who have me as their instructor of record. Okay, so do you see the difference between a population and a sample? All right, so let's work on this. Let's look at some more examples. In a recent survey, 1,500 adults in the United States were asked if they thought there was solid evidence for global warming. 855 of the adults said yes. All right, so we want to identify the population and sample here. We also would like to try to describe the data set. You guys are going to see similar problems when you come into the lab next week. All right, so what do you think would be the population and the sample here? Well, the population is going to consist of the responses of all adults in the U.S. Okay, so let's go back to the previous slide. In a recent survey, 1,500 adults in the United States were asked if they thought there was solid evidence for global warming. All right, we want to know how everybody in the United States feels about global warming. Does it exist? Does it not? But because we can't go around calling everybody, asking everyone, stopping everyone on the street, we have to use a survey. And in our survey, we asked 1,500 adults. All right, so I believe that there's a little bit over 260 million people in the United States. Technically, that is our population here. All right, and I don't know the exact number off the top of my head, but everybody living in the United States is our population. Our sample is just going to be the people that actually get the survey, the 1,500 adults. Okay. All right, the sample, again, is the subset of the responses of all adults in the U.S. All right, we're going to use these 1,500 people to represent everybody living in the U.S. since we can't feasibly ask everybody. Okay, and then if we want to describe our data set, what can we say? Well, we know that 855 of the people that we surveyed said yes, global warming exists. Since we know that we surveyed 1,500 people, we can take 1,500, subtract out the yeses, or the 855, and we know that that leaves 645 people who took our survey actually said, no, I don't think global warming exists. All right. We need to also define a parameter and a statistic. You guys, this is not hard, and you by no means need to put this in your short-term memory, all right? It's just reason. Let's reason this out. A parameter is a number that describes a population characteristic. All right, maybe we want to know if we're concerned with all people in the United States, maybe we want to know the average age of all people in the United States. Okay, so once we get into the course a little bit more, you're going to see Greek letters like mu and sigma, okay? And you're also going to see lowercase normal letters like a little s and an X with a bar on the top of it, okay? Anytime you see Greek letters, those are going to represent parameters. In other words, they're going to describe the entire population that we're concerned with. So here, if we wanted to think about the average age of all people in the United States, we're going to use our Greek letter mu to do so. And don't worry right now, like maybe some of you just think I'm mimicking a cow at this point. I'm actually saying mu, not moo. Just know I'm giving you a heads up that our Greek letters are going to represent parameters. All right, and then lastly, we have statistics here, and a statistic is going to be a number that describes a sample. All right, so let's go back to our last example. We had all people in the United States, all right, and if we wanted to know if we wanted to know the average age of all people in the United States, then of course we've got our parameter. If we wanted to know the average age of the 1,500 people that we surveyed, then that would be a statistic. It's representing our sample. Similarly here, we could take the average age of people from a sample of 3 states. All right, again, because it's representing our smaller sample, we're going to call it a statistic. All right, let's go through an example here and distinguish between a parameter and a statistic. All right, a recent survey of a sample of college career centers reported that the average starting salary for petroleum engineering majors is $83,121. Okay, does the average starting salary, the $83,121, represent a population parameter or a sample statistic? All right, well, the wording is there for us. Let's go back to the first 5 words, or 6 words rather. A recent survey of a sample. Okay, this number is coming from a survey of a sample. So right away we know that that $83,121 is indeed a statistic. Okay. All right, what about this one? The 2,182 students who accepted admission offers to Northwestern University in 2009 have an average SAT score of 1,442 or 1442. All right, aside from that being a ridiculously high average SAT, let's ask ourselves, is that SAT score a parameter or a statistic? Well, what are we looking at? We're looking at people who accepted admission offers to Northwestern in 2009. Is that a sample for something larger, or is that the population that we're concerned with? Well, since we don't read anything else of are we looking at admission offers to other schools, admission offers in other years, blah, blah, blah. We don't see that. We are solely concerned with students who accept admission offers to Northwestern University in 2009. Did we Did we get the average SAT from all of them? Yes, we did. We got the average SAT from those 2,182 students. Thus, what we're looking at here is that SAT score is actually going to be a population parameter. Okay, so again, that score is based on all the students who accepted admission offers in 2009 at Northwestern. All right, so what are we going to do with statistics this semester? We're going to look at two different branches. We're going to look at this descriptive statistics, and that is what we're going to be doing in Chapter 2, starting Labor Day week. All right, and so this involves organizing, summarizing, and displaying data. These are our tables, our charts, averages, standard deviation, range. All right, so these are some of the words that are going to come up. We're going to try to get an idea of how our data looks. Okay, we want to be able to describe our data. And then later on in the course, we're going to get into inferential statistics. All right, where we're going to use our sample data to make conclusions about a population. All right, so again, we're going to collect some data, we're going to do some analysis on it, and then based on that analysis, we're going to make conclusions about the entire population. You guys, we see this a lot in election years. All right, you'll know that, notice a lot of times CNN, Fox News, they report polls where, you know, maybe they've surveyed 2,000, 5,000 American citizens asking, you know, are they going to vote for this person or that person? And from those poll results, they draw conclusions about the entire population of what we're going to do when we actually go out there and vote. All right, so let's look at an example. All right, we want to decide which part of the study represents the descriptive branch of statistics. Okay, so again, what part represents the descriptive branch of stats? What conclusions might we draw from this study? Okay, so what do we have here? A large sample of men aged 48 was studied for 18 years. For unmarried men, approximately 70% were alive at age 65. For married men, 90% were alive at age 65. So what do you think are the descriptive stats here? In other words, we have this large sample of men, all right? We track them from age 48 to age 65. What do we know about them? Well, we know that the unmarried men, of the unmarried ones, only 70% were alive at the end of our study. That's descriptive. That's describing our data. All right? For the married men, 90% were alive when we got done with our study. All right? Again, that is descriptive. It's describing an actual situation we have in our data. All right, now let's look at it. All right, what conclusions might be drawn from this study? Is there anything you think we can draw? All right, well, obviously, it appears men are more likely to be alive at 65 when they're married. All right, and so a possible inference drawn from the study is that being married is associated with a longer life for men. All right, so what did we talk about in this chapter 1.1? I defined statistics for you guys. I distinguished between a population and a sample, something that you're going to do in the problem set. I distinguished between a parameter, a population parameter, and a sample statistic. Again, something you guys are going to work on in the problem set. And then I also distinguished between the descriptive statistics and the inferential statistics.